This second video of Module 12 looks at soil formation. So in talking about soil formation, it's useful to draw a distinction between what are called mature soils and immature soils. So let's take a look. So this is a cutaway view at some soils, and we have different layers that we call horizons shown here in this soil profile of a mature soil. And at the top, near where you see the trees, in this cutaway view here, we have the first horizon of soil called the O horizon, which is principally organic. So the organic layer of soil. Below that, we have topsoil, which is pretty high in organic content. And actually, the A, E, and B horizons are all considered topsoil layers. But the E and B horizons play a special role. And I've kind of alluded to this a little bit in an earlier video. And that's where gravitational water moving down through the soil will pick up nutrients, and I'm showing those nutrients as those yellow dots, and watch the yellow dots as they're picked up by gravitational water and pulled down and deposited through a process we call eluviation with an I. So this is what makes a mature soil a little bit different. It has this E and B horizon as part of the topsoil of the soil. Below the B horizon is the C horizon, which is principally inorganic in content. And then deep down below, where you can really see in this photograph, we have the R horizon, which is made up of just rock. Now, a comparison of a mature soil and an immature soil can be seen here. On the left, we have the mature soil that has the E and B horizon, so you have that process of gravitational water picking up nutrients, carrying those nutrients down, that's signified by the E and B horizon. In the immature soil, the one on the right, you see only the A horizon. There's no E or B horizon. So where might you find an immature soil? Well, probably in a mountainous area, perhaps one that has a little bit less rainfall, and soils are not going to develop quite as quickly in that type of environment. Let's talk a little bit about factors that hasten or speed up the rate of soil development. We'll just look at a few. Permeable and unconsolidated parent material. Permeable refers to the idea that water can easily move downward through soil layers. Unconsolidated parent material refers to where you don't have solid rock, where you have real soil, broken up material. Secondly, warm and humid climate. Anytime you have more warmth and humidity, and for example rainfall, you have faster soil development typically. More biological activity happening. Covering vegetation helps as well. Some factors that slow the rate of soil development include, sort of the opposite of the earlier example, impermeable material that makes it difficult for water to move down through soil layers. Hard and consolidated parent material like rock right at the surface. Cold, dry climates, so you take away heat or moisture or both, and that slows down the rate at which soils form. And finally, location on steep slopes. Let's take a look at some soil forming regimes or some environments, what we might refer to as local conditions that influence soil development. And I want to walk you through just 5 of these. One is a characteristic of where I'm making this video here, Oklahoma, the calcification soil forming regime. We typically find that in continental climates, as I say on the slide, with evaporation exceeding precipitation, with soils that have some clay content to them. And this is where you would typically see grasses and shrubs that we would associate with the North American prairies. So some evaporation that takes place, really a soil that is probably ideal for growing tall grass, like the tall grass prairie. So calcification soil forming regime. If you follow what happened with the Dust Bowl years in Oklahoma, sometimes farmers needed a very tough plow in order to break through that thing called hardpan, which formed at the surface where evaporation left behind this very sort of tough layer of material you had to kind of break through if you wanted to farm. The second soil forming regime I wanted to mention briefly is called glaciation. It happens in places like around the Great Lakes, where you find boggy, waterlogged areas in cooler climates. Lots of organic matter accumulates in these types of soils, so glaciation in cooler climates with organic material and boggy conditions. Laterization. Laterization is something we really find only in Hawaii when you talk about the U.S. or maybe a few other places like Puerto Rico, but not so much in the continental part of the U.S. So the example I have here, the red star, is over the Brazilian rainforest, and we might find laterization happening in warm, moist areas, old rainforests. Here we find speedy decomposition of organic material, lots of biological activity, relatively low soil fertility because of leaching. So there's not a lot of nutrients in the soil because most of the nutrients have been carried by gravitational water long ago. A lot of the nutrients are really in the biomass in the plants themselves rather than in the soil. Podzolization is something we find in cooler mountainous parts of North America where you might find coniferous forest. We do have sufficient moisture, as I say on the slide, for larger green plants, trees, to be able to do pretty well. But those cooler temperatures inhibit the growth of bacteria that you find in other places, in other types of soils. So podzolization in the cooler mountainous climates. And finally, salinization is a soil forming regime associated with arid and semi-arid regions that have pretty poor drainage, where water that drains down into areas, the only way for it to escape is through evaporation. So oftentimes salt is left behind in these areas, and salt isn't really very good for growing crops. Let's talk about, just for a moment, some factors that threaten soil. So we'll sort of walk through a little bit of a laundry list, and I should just say something briefly about Franklin Roosevelt. He was the president during the Dust Bowl era, and he was very aware of the dangers of soils being damaged. And we'll talk a little bit more about some things that Franklin Delano Roosevelt did. But one of the things I touched on a minute ago was this one, when we look at poor drainage, and those are situations where water is used for irrigation, but there's no natural place for the water to run off, to carry off that excess water, and where the water just evaporates and isn't really carried away to some other place. Oftentimes, salts will accumulate in those places. So poor drainage can lead to the buildup of salt, which is not really great for crops. Water erosion is another problem with some soils. This is an area of clear cut where really everything has been cut, not just the trees that people needed, but every bit of vegetation has been cut, and that can contribute to high rates of erosion. And dust storms are another, wind erosion, and we'll look at, we know that the Dust Bowl years were a time when wind erosion in that region of the U.S. that was covered by the Dust Bowl was quite a problem. And John Steinbeck, his book Grapes of Wrath is one that I've read, and I think it's really quite a interesting description of those years and the hardships that took place during those years. But the Dust Bowl region I'm showing here on the map covered much of western Oklahoma and the panhandle of Oklahoma, and areas in New Mexico, Kansas, Texas, and Colorado. One of the things I'm kind of proud of as a transplant Oklahoman are some things that were done by the federal government to try to slow down the rate of soil erosion. One of those things that was pretty successful were shelter belts. Shelter belts were trees that were put in oftentimes along sections. If you're familiar with sections or 1 square mile section line roads. And the idea of those trees is they would slow down the velocity of the wind, and in doing so, slow down wind erosion. And some of the first shelter belts were right here in Oklahoma. So we were a test area. This one's in Greer County, Oklahoma, that was put in 1935. Something else you can do is contour plowing. That helps to reduce runoff and soil loss. Another threat to soil is pollution caused by things like mining, other types of activities that are associated with water pollution that can lead to soil pollution. I wanted to say a few things about how soil is classified. So very briefly, the soil classification system that's used worldwide is called the seventh approximation. It came from a series of meetings of soil scientists where they had trouble really agreeing on very much at all. And when they finally met a seventh time, they came up with a hierarchical system for classifying soils. So they decided to call the system that they developed the seventh approximation. So it took those 7 meetings to come up with a name. They initially had 10 soil orders. That's the most basic way of dividing soils. And that list has been since expanded by 2, so we now have 12 soil orders worldwide. And then they came up with a way of classifying soils, that with more detail down to the most basic type of classification, the soil series. So soil orders, suborders, great groups, subgroups, families, and finally the series is kind of like when you're talking about species for plants and animals. Well, I want to walk you through briefly some soil orders of the world. We won't spend a lot of time with this, but I just want to get you sort of a sampling of these soil orders. And we start with the least weathered, so the least broken up, where we can see a lot of rock, a lot of the parent material here. So the least weathered, and we'll end with the most weathered. So we'll work pretty quickly through the list here. So entosols are often poorly developed soils, with, as I say, recent in origin, lacks horizon development. These are immature soils that are found on the sides of mountain slopes. So you see a lot of rock there. Entosols, inceptisols are similar. They're often also found on steeper slopes. They have minimal horizon development, so we call them adolescent soils. So again, not very well developed. Andesol, this is one of the soil orders that was added since the 7th approximation was created. These are volcanic ash soils. This particular soil order was added at the request of Japanese soil scientists because they said, hey, there's parts of islands in Japan that really aren't well represented by the other soil order categories. So this was added. These are relatively young soils, poorly weathered. Once again, the gellisols have also been added to the list since the original list was developed. These are soils of very cold climates that contain permafrost within the first 2 meters of the soil. Histosols are very organic. When I talked about glaciation a little bit earlier, this is a soil order associated with glaciation. So a lot of organic material, waterlogged much of the time. Common around the U.S. Great Lakes. So you can see the dark color of the soil sort of is a clue that there's a lot of organic material. Andesols are soils of dryland regions. As they say, they cover about 1/8 of the Earth's land surface. So these are soils of basically of deserts. So fairly dry soils have those kind of yellow color. Not a lot of organic material, much less than the histosols. Vertisols have a lot of clay in them. We have some vertisols here in and around Stillwater and throughout Oklahoma. So clay-like soils, they shrink and swell. So soils that you are oftentimes associated with the tall grass prairie that we have here in Oklahoma. Now, this is the soil order I'd like you to remember. This one in particular, the mollisols are soils of grassland ecosystems, including prairie regions. I know not everybody taking this class is in Oklahoma necessarily, but tall grass prairies are associated with the mollisols. It's the most productive soil order for agriculture, so it's great for growing things like winter wheat. And again, the soils that are underneath much of the areas of the Great Plains and covering much of Oklahoma, Kansas, and Texas, and elsewhere. So mollisol is a very productive soil order. And then as we move, remember we're getting to more weathered soils. Alpha sols are moderately leached forest soils with a subsurface clay layer found in sort of temperate, humid, and some subhumid regions. So these are found in throughout the U.S. Ultisols, strongly leached soils, acid-forward soils. These are found in humid, temperate, and tropical areas. So soils you might find in the Brazilian rainforest, but even more likely some of the soils are a little later in the list here. Spotisols, they have an alluvial or dark reddish layer. That's a layer that's been left behind by that process of eluviation with an E, depositing those materials through the process of eluviation with an E. So heavily leached soils. And then the very last soil is the most weathered of all. And again, you're going to find these soils in ancient equatorial regions of South America and Africa. These are not found really anywhere in the U.S. except for Hawaii. So the oxisol is very old soils.